So playing with my EPM1270, one of the things I like to play around with are R2R networks. They're pretty simple. Gives you the ability to actually do something simple and just look at the outputs with the scope and become more familiar with the hardware. If you're not familiar with an R2R network, it literally refers to R2R. If these R's are 100 ohms, these are 200 ohms. And what you can do is put a binary value in on these 8 pins and get an analog value out that kind of represents that binary value. In this case, the EPM 3.3 is 3.3 volt logic. And so what I'm going to do is, if these are all zeros, I'm going to get very nearly 0 volts out. And if they're all ones, I'll get 3.3 volts out. And as you apply the binary up count across these, that voltage will increment, swinging from the near 0 to the near 3.3 volt. There's all kinds of good resources online for R2R networks. You can find all kinds of information here. In this case, the R2R network I'm playing with is in a 16-pin dip, which is represented here by the red line, or brown line I guess it is. And what I've done is I've taken the 8-bit IO number 2, and I'm using it to drive this. And I've got a ground reference so I can measure the output. And I'm just using 8 of the IO pins on the CPLD device to drive this. So went ahead and designed this little schematic up and then wired this thing up. So as we look at taking the schematic and setting it up as actual hardware, I've kind of been digging through my bits and pieces to figure out how I'm going to do this. The WaveShare boards, of course, plug into a connector somewhat like this on the side of the WaveShare board. They're using little right angle connectors, although I decided these just set too high and wouldn't work for me. I dug around in my bits and pieces and I found these little long 0.1 center headers. And what I've done is I've slid 10 pins worth up through the bottom of the board and then bent them over at 90 degrees. And the idea being this will slide into the connector on the side of the WaveShare board. And I'm going to go ahead and solder these up on the plate through holes, and I'm also going to solder them up on these little larger pads here just for mechanical strength. I've simply got a little header slid on the end here to kind of hold things in better alignment while I do this soldering. From there, I'm just going to go ahead and use a 16-pin wire wrap socket that I'll drop into place. I will just use wire wrap to wire this up rather than do point-to-point soldering. I'll trim the pins off short enough that this will sit down and be able to plug into the WaveShare board. And there's a couple of 100 ohm resistors here that I'm going to use to try to attempt to create this virtual ground. This should be a pretty quick assembly. Anyhow, we'll step through here and see if I can kind of keep my hands out of the action here. I'm actually shooting with the camera directly in front of me, and of course I can't solder looking at the LCD itself on the camera. That would simply I don't get any depth of field. So anyhow, let me tack a couple of these pins here. These wrap header, or these pin headers that I've got here, these guys really don't take solder very well. They're old, but they're pretty much junk. I don't know where I got them. I've tried to use them in multiple projects before I realized that they really don't take solder well. I could probably do a bit of cleanup on them, maybe remove some of the oxide and get them to solder better. I've quit using them in anything that I need to have any lifetime to it. This project's more of an experiment than anything else. But anyhow, we'll solder this up as best we can. Come back, wire wrap it, and see where we end up. And I'm not working at a comfortable working distance for me because of my glasses. Not being able to see is always a challenge. Let's see if I can find a good angle to get down inside of there. I don't want to bridge these, but I do want to get some solder under there just to add some mechanical strength to the build, hold these pins a little more rigid. Hopefully we're getting good focus here. I don't know if we are or not. Sounds to me like a video I was rendering downstairs is finished. I can hear it playing back. So that'll be a video. It'll be posted ahead of this one. This video's been a long time in the making. There's a little bit of solder up underneath every one of those. It's a pretty lousy job, but it works. And the idea here is I've got the 10 pins here, and they'll just slide into the WaveShare OpenEPM1270 board the same way the little cards it came with did. Actually, I'm going to leave that on there just to help protect those pins. I've got a couple 100 ohm resistors here. Well, that didn't work as well as I would have liked. Again, these are for trying to create that little virtual ground. I don't know how well that will or won't work. Pin 1 is up here high. And I'm just going to drop those in. And I will cheat here, and I will wire wrap directly onto the resistor pins as well, and then just come back and hit it with some solder. Not the most reliable connection methodology, but again, for my purposes here, it'll be absolutely fine. Actually got that spaced a little bit different. I'd like these spaced the same. Just for aesthetics, I've got just go to there. Just put a bit of solder on those just to kind of hold them in place. I've mentioned this before in videos with wire wrapping. Wire wrap pins have typically square pins. They have sharp corners to them, and the idea being as you're wrapping, the wire is pulled very tight up against that square edge, and it kind of digs into the wire a little bit and creates a gas tight connection at that point, and that's part of what gives you the reliability. So we can take this 16 pin wrap socket, and we'll just find a spot here on the board. 16 pin wrap socket I won't solder in because I'm going to trim the pins on it, which will make it a bit difficult to reuse. The pin lengths here are a little long. This will ride too high to plug directly in, which is why I need to trim the pins off so that the height is low enough that it'll plug directly into the EPM1270. There's that piece of it. Maybe I just will go ahead and tack a couple pins on this. No, I don't need to. Anyhow, there's the first part of that. I will move on to finding my wire wrap tool and some wire wrap wire, and we'll come back and wrap this guy up. So I've grabbed 3 different spools of wrap wire. I will use the black, of course, for this ground connection. I'm going to use the red for the power connection, even though in my mind red means +5, but this is a 3.3 volt railed part, but that'll be fine. And I'm going to use the blue to hook the bits up, and then I will of course need to get 3 other connections on here to come out and to connect to an oscilloscope. One of the things here, see if I can get focus on it, is this little card here. It's a wrap ID that I'm just going to go ahead and use that. It simply goes on the back of the board here over the pins. If I can get it to line up. These wire wrap sockets have been used and reused a number of times. They're rather old. Pins aren't as square as they could be. I technically don't need to do this for something this simple. These are not cheap, but they're not expensive either. Get it slid down on here. And all it does is make identifying the pins as I'm wrapping a little simpler. On large boards that I've wire wrapped, I use these just because you can see it numbers the pins from 1 to 8. You know, realizing that pin 1 is in this corner here and 16 is up here. When you flip it over, of course, it's backwards. So let's make it a little easier to make sure I get this right the first time. You know, not a huge thing. In the wrap tool, in the handle here is a little stripper. The first thing I need to do is get me a piece of black wrap wire, and of course this assumes I can find the flush cutters. So we'll just get a piece of black wire here. I'm going to waste some. That's awfully long for what I need to do, but it's easier to strip with some length. See if I can get focus here a little more into where we're working. Typically you strip about 1 inch. I'm not going to be stripping quite that much, simply because I don't need to. I get it into the tool. We know that looking from the top down, this pin 2 here is ground. Just made a little connection there, and in this case I'm just going to go straight to this resistor here. Give myself enough lead here. Strip that. Feed the wrap wire into the tool, and of course I'm again working around a camera and I'm somewhat blind, and this is not a recommended construction technique if you're going to do anything that needs to be reliable. Wrapping onto like a resistor pin or a capacitor pin. All I'm going to do is trim the resistor lead back, and I'll come back and solder those. The middle 2 pins is where the virtual ground will get picked up, and this end over here will pick up the 3.3 volts. This could be just as easily point-to-point wired. The more ambitious of you might design a little circuit board. I'm not that ambitious. Why, there we go. I did not want to feed in there. And of course pin 1 on here brings out the 3.3 volt rail. This is going to come off to this pin here. And as always, the tools roll off and go flying in every direction and make the job that much more interesting. Let's get on to this other side over here. We'll just wrap onto it. I'll go ahead and trim it. And that wire's a little tight, but that's okay. So all we've done is just taken 2 resistors, in this case 200 ohm resistors in series between 3.3 volts and ground, and the idea is to create a voltage reference that'll be at about the middle of the 3.3 volts. So what's that, 1.5? I can't do the math here in my head. Anyhow, around almost 1.6 volts, 1.65 volts essentially. And the idea is with the virtual ground is this output is being driven from 0 to 3.3 volts and back to 0. As we send the sine wave bits out, it'll appear to swing above and below this virtual ground, or you could just compare it to the ground here and see it swing from 0 to 3.3 volts to 0. I'm assuming this virtual ground will work. Maybe it won't. I have no idea. It should. But those are famous last words. Anyhow, we've now got 8 pieces of wire we need to track. And just so this is clear here, the red outline here represents the 16-pin dip. And this is pin 1. This is pin 8. This is pin 16 here. This is pin 7 here. And the idea, I mean, I just dropped this in the same pin out. This is the electrical pin out for the R2R network. I think we looked at this in an earlier bit of video and a quick idea about how that works. And I just grabbed that piece of the schematic, spun it around here just to come up with a wiring diagram. So of course with this way, pin 1 is up here, but when I flip it over, pin 1 is down here. But what we're going to do here is just grab some blue wrap wire. Again, apologies, I'm working around the camera and probably bumping it well. And the wrap tool. And this just should wire one-to-one directly across, kind of making this easier. So as soon as I can get the wrap wire into there. So pin 1. Should just come to pin 3 here on the header, and they should just wire directly across. And that's why I positioned the wire wrap socket the way I did. It's just directly pin to pin. You know, this could have been done with solder bridging or other ways on the board. There's a ton of ways it could have been done. This is just the way I chose to do it. It's not better or worse. It just kind of is what it is, using the tools I'm familiar with. We'll grab the end pin down here. And bring this out and give me some length. And we'll strip that one. So looking at the little stripper tool here, let me see if I can get focus on it. You can see that it's got the little black metal insert that's the actual stripper, and it's flush on one side. And so in this case, I'm rotating it up, and I'm coming here, and that way, where it's cutting into the wire, if I can get focus there, is a little bit of distance away from the pin. And that gives me room then to get the wrap tool on. Get a little bit of insulation up into it and do just what you saw me do there. And let me do the other pin. Try to shift the focus here. We'll do the same thing again. So what it does is it gives me a little of insulation beyond the pin I want to wrap onto. And that way when I get on here and wrap, I get a little tiny bit of blue insulation wrapped around the pin. I'm trying to shift focus here. Hopefully that shifted. And you can see that I got a little bit of blue insulation around the bottom of both the pins with the wire ran in between. You know, it's just a way of doing it, but you can take advantage. You can take advantage of the thickness of this just to help you gauge where you're wrapping to. Again, I'm not an expert. I don't claim to be an expert. I've just been doing this for a lot of years. I've wire wrapped a lot of boards in my time, both stuff that become productional and stuff that was just pure hobbyist or was prototyping. You know, I have done a lot of wire wrap joints, not nearly as many as I've soldered, but but I have certainly spent a lot of years with a wire wrap tool in my hand. Oops. Wire slipped out. That's okay. Didn't leave myself quite as much length on that one as I would have liked, but that's okay. At some point, I'm going to be curious about using some R2R networks like this to see if I can essentially generate 24-bit analog VGA with 8 bits per color. You know, you've seen on a lot of VGA implementations on, you know, microcontrollers and that kind of stuff, where, you know, you've got 2 intensities, or really 4 intensities, color off, and then 3 intensities to full brightness. And you can do pretty nice stuff with that, but I'm just curious if I could get, you know, 8 bits or 256 degrees of red, green, and blue, and what it would work like. I mean, essentially this is a digital to analog converter here. Not a great one, but it's a very common design. Oops. It would help if I could hold on to the board. Hopefully the focus is somewhat on the board here. And you may have noticed I'm choosing to do these 2 at a time, working from the outside in. Could have done them 1 wire at a time, or all 8. Again, kind of what you're comfortable with. Because when I thought about the mechanical layout of this, it was just so simple. It's just 1-to-1 wiring. It evolved out the way it you know it is. I did think about the mechanical assembly of this a little bit before I started assembling it, just because that always helps. It's very easy with wrap wire to get a rat's nest very quickly, and I can tell you from experience, 1 miswrap in 1,000 wraps can be really difficult to find. And if you've used all the same color wire, it can be nearly impossible. When I've done complex wire wrapping, you know, I've got a whole selection of colors of wrap wire here. And I tend to do white for control signals, blue for data, yellow for addressing, etc. So you at least get some kind of representation visually when you're looking at the rat's nest of wires of what they're supposed to be. Anyway, that's squeaking. It sounds like I need to oil my wrap tool. Yes, I'm kind of joking there. I guess I could put a little drop like silicone lubricant up in that end. But a manual wrap tool like this doesn't really need lubrication. I'm sorry, I'm doing that completely off screen. I'm shuffling things around to where I can see and not where the camera can see. Apologies. A little bit of difference in length there. Not that it really mattered. Now, of course, doing this the way I'm doing it, where I'm wrapping one side and then stripping, does put stress on the wire and could potentially break the wire inside of the insulation. I'm well aware of this, and as I've said a few times, this is not meant to be a permanent build or productional build. Nobody's going to die if this fails. It's just kind of an experiment to see what I can do. So we've got all 8 of the data pins connected to pins 1 through 8 of the R2R network. So again, pins 1 to 8 of the R2R network. Least significant bit coming over to IO42, and it works its way up all the way to IO51 where the most significant bit is. So to me, this just kind of is nice in that it goes least significant on 42 to most significant on 51, least significant to most significant. It just makes it a little easier to keep the schematic in my head. Next thing we need to do is figure out how we're going to get signals off board here to get the scope hooked up, and I guess I just need to put some pin headers in here and hook those up. So let me go find some more pin headers. So I think to bring the signals off the board, I'm going to do something very similar to what I did getting the signals in, and that is I'm going to bring the pin headers up to the bottom of the board. Oops, I didn't mean to zoom there. I meant to focus. I'm going to bring them up this way, and they'll be ground, virtual ground, and signal output in some order. Those will get wire wrapped in place. It will trim the pins here on the wrap socket, and that way the board will just be able to sit kind of on this set of pins on both sides. It's somewhat cheesy. It'll work. It's not elegant. I'm choosing to put 2 pins in just so I've got a couple different pins to capture a ground on, or a scope probe too. Get some solder on one of those and see how square that is. And it's square enough. I'm not super worried about, again, how mechanically beautiful this build is. You know, I think I've mentioned this earlier, the ultimate goal here is to use an 8-bit sine wave lookup table to feed the inputs to this in Verilog off of a clock divider chain. I think that'll work. I need to bring a ground over. Ground to be these bottom 2 pins. So I'm going to do a big cheat here. I don't necessarily recommend you do this, but I'm going to strip off a large section of wrap wire, and I'm going to wrap part of this around the first pin and then reposition the tool and finish wrapping it onto the second ground pin, assuming I can get the wrap wire to actually stay. Oh, come on. Come on, quit pulling back. Get several wraps on there. Then I will take and reposition the tool over onto this pin and wrap onto it. And as cheesy as that is, it did wrap those 2 together. And then I need to route this over here to pick up ground. Again, certainly not a beautiful wrapping technique. But it is what it is. A little bit of extra wrap wire there. also to find the right pliers here. That's the one with the broken tip. It's amazing how the tool you need is never the one that's laying on the bench. Trying to think of the best way to get in here and do this. Can't. That's really not going to work. I'm just wondering if I can wrap over both of these resistor leads at the same time, and I really can't. So what I'm going to do is take one of the resistor leads, and I'm just going to bend it over. If I can find a tool here to do this with. Actually, I want to go the other way. I want to come around to this side. That lead. And I'm just going to kind of wrap it around the base of the other resistor lead. Like so. I'll trim it back, and when I come back and actually solder these connections up, it'll give me a sufficient connection. That did not strip well. Nope. You saw me break the wire there. That does happen. I'm going to do the same double wrap technique for the virtual ground pins. Again, I don't recommend this. It's just something I've done over the ages that's worked okay for me. Over onto the second one. Get him wrapped. This is going to come over and pick up the quote virtual ground. Again, hopefully some of this is ending up in camera and somewhat in focus. Resistor lead. Not as happy with that as I could be. Solder to make that somewhat permanent. I do need to get the two resistors here tied together. Just being a little bit stubborn. Should have done that before I wrapped onto here. A little solder on that resistor lead. A little solder on that resistor lead. And we've got our ground, our virtual ground, and now we just need to pick up pin 16. Which is the output here. Certainly not the best wrap job I've ever done. Sorry about working off camera again. 116 is right there. It's going to come over to here, and I need a fair amount of length here because I'm going to do that double wrap thing again. Take a little bit more insulation off of that. So this is obviously not meant to draw or to drive, you know, low impedance loads. It's not going to drive a speaker or anything like that. It's simply for generating a voltage reference that we can see on the scope. If I decide to drive something else from it, I will need some kind of amplification. So we got ground, virtual ground, and voltage out. As I did say, I'm going to come along and shorten up the pins on the wrap socket. Got something a little hokey there. Did not quite get wrapped all the way. Board will sit like so. It'll plug into the EPM1270 using this set of pins. So I guess the final piece we need to find here is an R2R network. And a little bit of advice. Always put the wrap tool stripper back in the handle. It's tiny and very easy to lose. Let's take a look. I know I've got some dip ones in here. A little bit of information I collected. This is probably the data sheet. It's going to be one of these guys, and I think I just got two different values here. Having a hard time reading that. 4116. I'd like to read where it says R2R. Yeah, R2R. Any one of these should work. These are a little wide because they're new parts. Pin 1 to pin 1. And we've got our little R2R board to use with the EPM. Clean up here. Stuff put away. And we've taken schematic here and translated it into hardware. This little 10-pin connector here is the pin out shown there. The R2R network, the 16-pin dip, is in the same orientation here. And we've created three outputs. They just happen to be reversed ordered. It's ground, virtual, and signal out. So I'll be curious to see what we can make that do.